Hello mathematicians. Today we see one very simple problem from real analysis. So it is basically about the bijections between the open intervals, closed intervals and so on. So there is a one simple approach to find bijection between two arbitrary open intervals. So you take some interval like open interval root 2 comma root 3 and another interval open interval 100 comma 300. How to construct a bijection between them? So there is a very simple way to construct a bijection between any two open interval a comma b and c comma d. A b c d are any numbers. Okay. uh, how to construct a bijection between them? That is a uh, uh, that is the essence of this problem. So let's see the problem. So A is given that set of all x square such that 0 less than x less than 1. And B is given that set of all x cube such that 1 less than x less than 2. Then which of the following statement is true? There is a one-to-one onto function from A to B. Basically, they are saying that there is a bijection between A to B. There is no one-to-one onto function from A to B taking rationals to rationals. So you consider all the rational here and all the rationals here. They are saying there is no there is no bijection that takes rational here to rational here. That is the second option. So maybe remaining option will come back later. Let's just figure it out. First two options. Very first thing is, if 0 less than x less than 1 and you calculate the x square, okay, then this image will be always in 0 comma 1 only. Okay. So why is it so? Because you take any number in 0 and 1, its square will be always a number between 0 and 1. For example, if it is 1 by 2, its square will be 1 by 4. If it is 1 by 3, then square will be 1 by 9. So all this number will be again in 0 and 1. Okay. Therefore, the set of all x square is such that 0 less than x less than 1 is precisely again open 0 comma 1 only. Okay. Similarly, all or you can see that like it is a continuous function. So continuous function, even it is an continuous increasing function. Like you all know how the graph of f of x equal to x square looks like. So you see here it is increasing in 0 and 1. So yeah, f of 0 is 0, f of 1 is 1. So remaining points will be mapped between 0 and 1 only. Okay. So A is 0 comma 1. Similarly, if you draw the diagram of f of x equal to x cube, again that is also an increasing function. Maybe I'll, so yeah, so f of x equal to x cube graph will be like this. Okay. So again it is increasing in the positive side. So what happens is, so image of 1 will be 1, image of 2 will be 8, and since it is an increasing continuous function, in between points lies between 1 and 2 has to be mapped between 1 to 8. Okay, since continuous image of a connected set is connected, 1 comma 2 is a connected set, so its image has to be a connected set. So since 1 goes to 1, 2 goes to 8, the middle point has to go to open interval 1 comma 8 only. Okay. So we conclude that A is open 0 comma 1, B is 1 comma 8, and the first option says that there is a bijection between 0 comma 1 and 1 comma 8. So this set has cardinality 2 power all of naught. This set also has cardinality 2 power all of naught. So any two sets have same cardinality, you can always find a bijection. That is a, in exam, that much is enough. But in many interviews also they have asked this question. Okay, so and in some other problem they gave the bijection between two intervals. Then they asked between what interval they are bijection. So the detailed explanation will be very helpful in solving other problem also. So let's see. First we do option 2. They're saying that there is no one-to-one onto function from A to B taking rationals to rationals. So now rationals are countably infinite. So we can enumerate them. So let R1, R2, R3, etc., etc. be rationals in open 0, comma 1. Similarly, we enumerate the rationals in open 1, comma 8. Say S1, S2, S3, etc. be rationals in the interval 1, comma 8. So once you enumerate it, then you can just map it like this. R1 goes to S1, R2 goes to S2, R3 goes to S3. This will give you a bijection between rationals in open 0, 1 and rationals in 1, 8. Okay, very good. So anyway, option 2 is false for this reason, because they are saying there is no bijection, but there is a bijection. We just saw that. So option D is wrong. Second option is wrong. Let's construct a bijection between open 0, 1 and open 1, 8, so that the first option is correct. Let's see. So first we construct a bijection between closed 0, 1 to any closed interval a, b, such that 0 is mapped to a, 1 is mapped to b. Okay. So let's look at this image. So this is our 0, 1. This is some interval closed a, b. So what we do is we map 0 to A and 1 to B. Okay. So then we just draw this line. Okay. If you look at this line given in the rose pink color, so that defines a continuous function clearly. Okay. And it is an increasing function also. That is fine. But what it is, this function defined on close 0, 1. And if you draw any horizontal line in the interval closed a, b, it touches the curve at least one point. Okay. So what does that mean? If any horizontal line touches the curve in the codomain, means that the function is onto. Okay. Yeah. So anyway, we are going to verify that it is a bijection. So we just we we just want to find the equation of this line. So this line in the R2 plane passes through the point 0, A and 1, B. Okay. So x-axis it is 0, y-axis it is A. In x-axis this is 1, in y-axis it is B. So this point is 1, B, this point is 0, A. Well, how to find line joining 0, A and 1, B? So line joining x1, y1 and x2, y2. This is the formula: x2 minus x1 by x minus x1 equal to y2 minus y1 by y minus y1. So if you substitute the points 0, A and 1, B for x1, y1 and x2, y2, and if you simplify, you get y equal to b minus a times x plus a. So this is again all school stuff. Then you remember y equal to f of x. That's what we substitute in the school, because y axis what y axis is always the image axis. Okay, that's why we substitute y equal to f of x. So if you substitute y equal to f of x, we get f of x equal to b minus a times x plus a. Now in this function, if you substitute 0, you get this term vanishes, so you get a. If you substitute 1, if you substitute 1 here, you get b minus a plus a will get cancelled, you get b. Okay. So this is a function that takes close 0, 1 to closed a, b. Okay. And if you draw the curve of graph of this curve, that graph is precisely this straight line joining 0, a and 1, b. Okay, very good. Now okay, since so it is a function from closed interval to closed interval, and this 0 goes to A and 1 goes to B. Okay, therefore it is a bijection also. We'll see why it is a bijection. For the time being, you assume it is a bijection. Now, so since 0 goes to A and 1 goes to B and it is a bijection, we can restrict the function to open 0, 1, open A, B. Okay, because in the domain we removed a point and codomain we removed its image. In domain we removed a point and codomain we removed its image. So then it is fine. So the remaining function will be always a bijection. Okay, because 2 points is removed in the domain, 2 points is removed in the codomain. Therefore, the bijection will remain a bijection. So this defines a bijection between open interval to open interval. So same function only, we are saying that we can restrict it to open intervals also. It will remain a bijection. Okay. So now maybe let's see why f is a bijection before continues further. So to show f is a bijection, we explicitly construct the inverse. Okay, once a function has inverse, that means that it is a bijection. So what is f of x? F of x equal to b minus a times x plus a. So to construct its image, what you have to do is you solve for x. Okay, so now x equal to y minus a by b minus a. This x is, if y equal to f of x, then x is the f inverse of x. Okay, so for x you substitute f inverse of x and you replace this y by x. Okay, you can keep it as y also, but it is variable. We always use x. So this is very important step. You replace x by f inverse of x and y by x. So we get the f inverse of x equal to x minus a by b minus a. And if we substitute f inverse of a, we get 0. If we substitute f inverse of b, we get 1. So f takes 0 to a, 1 to b. Therefore, f inverse should take a to 0 and b to 1. So that condition is clearly satisfied. Okay. Uh, Therefore, f inverse is the, now, okay, we got a function inverse. Let's see why it is a inverse of f. So we calculate f composition f inverse. So we should get it is an identity function. If we get identity, then this function, whatever we get here, this function x minus a by b minus a, that should be the inverse of f. Let's see. So f composition f inverse of x equal to f of f inverse of x. F inverse of x is x minus a by b minus a. So what f does? F of x equal to x times b minus a plus a. But if you substitute this value here, what f does? It will multiply this quantity by b minus a, then it will add a. That is our definition of a. See, whatever you put, x will multiply b minus a to that, then add a. So we get f of x minus a by b minus a equal to this quantity. Now b minus a cancels and a also cancels. We get x. Therefore, the function f has an inverse. Therefore, f is a bijection. Okay. So from open 0 comma 1 to open a comma b, we got a bijection. Now we need a bijection between any two intervals, open a comma b and open c comma d. What will we do? From open a comma b to open 0 comma 1, we can go using the function f inverse. Okay. Then to 0 comma 1 to c comma d, we can go using the function g. Like in place of open a comma b, we replace c comma d, then we get g of x equal to d minus c times x plus c. Same bijection, but in place of a comma b, I replace c comma d. So that will give us a bijection g. So now f inverse composition g will give us a bijection from a comma b to c comma d. Okay. Therefore, so first we have to apply f inverse, then g. Therefore, it is G composition F inverse. In G composition F inverse only, first we apply F inverse, then G. Okay. So G composition F inverse will be a bijection between open A comma B to open C comma D. Therefore, between any two intervals, there is a bijection. Okay. You can even simplify what is G composition F inverse because we know what is F inverse. Uh, yeah, you can try to do it. You try to find this function explicitly. What you have to do? So you want to find G composition expression for G composition F inverse of x. That is G of F inverse of x. Okay. What is the formula for F inverse of x? F inverse of x will be x minus a by b minus a. X minus a by b minus a. Now, what is the definition of G? G will multiply the x by d minus c and add a c. So, we have to multiply x minus a by b minus a into a d minus c plus c. So, we get d minus c by b minus a times x minus a plus c. So, what is this? This is G composition F inverse of x. Okay, now this is a bijection between open a comma b to open c comma d. Why? You substitute the G composition F inverse of a. What will you get? You will get d minus c by b minus a times what is x minus a. In place of x, you have to substitute a. You will get a minus a plus c. So this is equal to c. So a is mapped to c because this term vanishes. Now G, similarly you can check that G composition F inverse of B equal to D. B equal to what we get, D minus C by B minus A times B minus A plus C, right? So we get D minus C plus C because these two terms will cancel, we get a D. Okay. Therefore, A is mapped to C, B is mapped to D. Okay. So so actually the bijects by the from A comma B to C comma D, this function D minus C by b minus a times x minus a plus c, that is the required bijection, explicit bijection between open a comma b to open c comma d. Okay. Okay guys, I hope you understand this function, this problem clearly. If you have any doubts, please let me know. If you like the video, please like, and if you haven't subscribed to my channel, please subscribe, so that whenever I upload a video you will get the notification. Please click the bell icon also. Okay, and share with your friends. Okay guys, take care, thank you.